Hey, this is Nick with Endeavor 3D. We're going to be talking about AM Polymer quality control best practices today with Hughston Young. He's our quality control manager here at Endeavor 3D. So what we're going to be talking about today is AM Polymer quality control best practices. A couple of the notes that we're going to be talking about today are going to be things like setup for success, material management, printer maintenance, post-processing controls, and product inspection. Today's presentation is scheduled to take 25 to 30 minutes and be recorded and available on demand. Please use the chat box to submit any questions you might have for the Q&A at the end of the presentation. So a little bit about Endeavor 3D. So we were founded back in September of 2020. We joined HP's digital manufacturing network in 2023. Basically, we became one of 5 digital partners who works with HP in North America. Essentially, if you called HP and asked them for a recommendation on somebody who they trust to work in the HP additive manufacturing space, we would be somebody they'd probably recommend. Following that, in August of 2024, as part of our commitment to be committed to quality, we became ITAR registered. This is in conjunction with also our ISO 9001 certification as well. Back in 2024, we did an additive manufacturing survey report, and we found some really interesting stuff. Some of the things we found were based on the survey that we ran with everyone from engineers, design work, R&D, CEOs and presidents, business and sales, as well as some others. But the predominant group that we worked with was engineers and design work teams. Across the industries, this was everything from automotive to aerospace, medical, industrial, you name it, they had it on here. And a lot of the people we ran the survey with also had over 5 years of additive experience. Again, this was conducted back in December through using Endeavor 3D and 3dprint.com subscribers. We had over 160 responses to this as well. What we found from the survey was quality matters. Some of the top 3D printing issues that people ran into were things like inconsistent surface finish and their parts warping and distorting. This was the vast majority of what people found to be an issue that they ran into with quality, with 80% of respondents saying quality is part of parts is the most important factor when choosing a service provider. So again, we found that when people were looking for parts, while price, lead time, things like that are really important, quality was really the thing that took over for them. And in that note, that's where Endeavor 3D can really come into play, because our commitment to quality is really one of the most important things that we focus on here. We're the largest 3D printing contract manufacturer in the Southeast United States. And we're also, as I said before, committed to being certified and also working with people to make sure that we're ISO 9001 certified, and we're also ITAR registered. And again, we're partnered with HP. We're also partnered with Dimension to make sure that we're having as much communication as possible with the vendors we use to bring parts in, as well as having them post-processed. Now, I'd like to take a second to introduce Hughston Young. Like I said, he's our quality manager over here at Endeavor. Hughston, it's great to see you.
Yep. So thanks everybody for being here. So I'm Hughston Young, the quality manager here at Endeavor 3D. Been with Endeavor for a little bit over 4.5 years now. So since the beginning, really. Some of my responsibilities in Endeavor 3D are managing the quality department, including quality control, quality assurance, material property testing, and managing our quality management system as well. So we can go ahead and get things started. Jump to the next slide, Nick. So jumping into our first section for today's webinar, if we want to talk about quality control best practices, then we need to start at the beginning. So we need to set our quality control team up for success. So then the question becomes, how do we do that? So next slide, Nick. So first, we need to understand what we're asking for. And we're asking a quality control team to control the products that are being produced in order to actually meet or exceed our customer requirements. So the first step to this process is understanding that quality is the ability to meet requirements. Next, whether you're an OEM or a contract manufacturer, you need to define or capture the requirements for the products that you're actually going to be producing. Next slide, Nick. So next, you need to know what your requirements are. So if anybody here today has ever had a problem with customer satisfaction due to quality escapes, one of the first things you should look at is, have you properly defined or captured the requirements of the product that you're producing? And is that information available to your quality control team? Because one of the greatest issues that a quality control team faces is not being provided the right information to be successful. So, and that's because as a quality control team, you can't control what you don't know. So best first practice is to capture those customer requirements. There's no prescriptive way to do this. So it's up to you as a company to determine how to do it. But we find that an engineer review typically gets us where we need to be. And the picture in the slide here is actually pulled from our MES system, COEM, where you can actually mark STLs on each order to identify specific requirements of each part that we're actually going to be producing. So this gives us some more visualization to some of the part requirements that we actually encounter on a day-to-day basis. Next slide, Nick. Another important takeaway is understanding the role of your quality control team. So this is important for setting up expectations as a company for where control is going to be needed within your production process. So here we have a very simplified version of our workflow at Endeavor 3D. It's much smaller than the real version in order to actually fit it on one slide and allow it to be scaled enough to where you can actually read it. But here we've defined 3 critical points in our process that need control. That being material receiving inspection, in-process inspection, and a final inspection. And this is very standard throughout many industries, but it's your responsibility as a company to define where these controls are needed and what the capacity, limitations, and expectations are for your quality control team. Next slide, Nick. All right, so following into the next section, in order to control the products that you're going to produce, you need to control the inputs into your systems. And that's where we come into material management. Next slide, Nick. So manufacturing 101, good inputs are going to give good outputs. So you need to know the materials you're actually working with and work with a material manufacturer to ensure that you have the proper environmental controls and storage controls necessary for the materials that you're using. So ensure that you're receiving at the very least a CFC from the supplier, and make sure that your CFC is recorded for traceability purposes too. Next, you're going to want to determine the most effective way for you to evaluate the materials that you're using in process, especially with powder-based technologies. So we created a powder cube that's printed in the center of each build. And with MJF, you'll typically see the most powder degradation at the center of the build. And that's why we capture a small amount of powder for testing from each build that we print. So finally, you want to make sure that you're also training your operations and quality control team over what bad material looks like in process. Otherwise, you may end up introducing overly degraded material back into the process and cause a high scrap rate or product failures in the field. And that's actually what you'll notice in the pictures on the left side of, the right side of the slide here. There are a couple photos of some bad powder that's actually clumping together, and this would typically be discarded on our end, specifically we use the MJF. But the important part to that is that if you don't properly train your technicians on what that bad powder looks like in process or bad material, it may end up back into your process and causing issues down the line. Nick, if you jump to the next slide. So the next thing that's important is obviously we know that we need to manage that material, but how do we actually evaluate that? And so for us, since we gather a small amount of powder from each build, when we take that into the lab, we run it through our X-Rite VS3200 spectrophotometer. And this piece of equipment allows us to accurately measure the yellowing of our powder, which has a direct correlation with the mechanical properties of the actual material itself. So now each material that we print with has its own tolerance in this test. But for example, on the right side, you'll actually see a picture of a reading from a powder cube of PA12, which is the most common material that we run. And in this specific test, our tolerance is between a 0 and +5 on the B scale. And so basically this is showing us that that powder cube that we printed with, that material is still good to go. And previously we mentioned the need for identifying the places in your process to institute controls or inspections. And so this is an example of how we identified a risk in our process and then defined an evaluation method and allocated the necessary resources for the quality control team to be able to evaluate the product or the powder in process. So for best practices, you want to look into doing the same for your material management. And as another example, if you're running FDM systems instead of powder-based systems, you may want to look at getting a dry box in order to keep your filament dry and allocating the necessary resources for evaluation equipment as well. But once again, it's up to you as a company to determine how to institute those controls into your material management, but it is most definitely in your best interest to do so. Next slide, Nick. So now we're going to move into printer maintenance. Next slide. So when we talk about quality control best practices, sometimes we neglect the role that our operations or maintenance technicians play in controlling the products that we actually produce. And one of the big ways to set your quality control team up for failure is by not giving system maintenance the attention it requires. Because you can know your requirements, you can feed your system good material, but if you fail to properly maintain those systems, then you're always going to struggle to produce quality products. So you need to set controls for the maintenance of your systems. You want to define maintenance plans, schedules, work instructions, training programs, periodic quality checks on your equipment. How many times, for instance, have you probably had a system that's gone down, needed to have maintenance done to it, system, and then gets back up and running and continues to repeat the same issue? Because more than likely, the root cause of that was the technician performing the maintenance was just skipping a step in the process. So once again, set your teams up for success, create infographics, work instructions, training programs, scheduled downtimes, maintenance audits, and checklists. So whatever's going to work for you and your process to maintain your systems to allow you to keep producing products that are going to meet requirements. At Endeavor 3D, we actually utilize HP's Train to Maintain program for our technicians. We have infographics for work instructions at each printer. We schedule progressive maintenance based on the number of builds that we actually run. And then we utilize COEM in order to actually schedule our machine maintenances, keep a record of who performed the maintenance, what level it was, and when it actually occurred as well. This way we can minimize maintenance-related issues that cause defects in products down the line. You can jump to the next slide, Nick. So post-processing controls. So you already know your requirements. You manage your materials. You have a strong maintenance control for your systems. So that leads us into now post-processing. Next slide, Nick. So as we actually kind of saw in the survey from 2024 that Nick talked about earlier, 55% of the people that voted that the barrier to entry into additive as a solution for their manufacturing process was actually inconsistent surface finish. So to combat that, we adopted the full dimension suite of post-processing equipment into our process. And that was mainly due to the automation that's incorporated into their system. This automation allows us to actually set standard programs for our technicians to run. And this helps to eliminate as much potential for human error as we reasonably can. These programs also tie in nicely to work plans that we use through COEM. And so just kind of going over the equipment in the slide here, starting from the left, we have our PowerShot C machine. This system is used to depowder our parts after they've been unpacked from their build box. The media being used is a polymer coated spherical glass bead. And so that media being polymer coated allows for a little bit more longevity on the media and also helps alleviate some of the potentials for the glass beads breaking, chewing up the parts, getting a rough surface finish, all because the technician started using a higher blasting pressure than they were supposed to, and you didn't catch it quickly. So one of the big reasons behind that media that we use there. The next one to the right of that is actually the PowerShot S machine. So this system actually is used to give us a much smoother surface finish than you would typically see from most blasting systems. However, the real magic from that is the cylindrical blasting media that's actually used there, and it does a really, really good job at that. Finally, we have our PowerFuse S and our DM60 die machine. So both of these systems allow us to have an additional level of post-processing or finishing for our products. that being vapor smoothing or dyeing our products a different color. And so, as I kind of mentioned before, these systems have really helped to streamline our post-processing and gives us the ability to standardize the surface quality of our products. And so naturally then, the kind of next step is discuss if we have the post-processing equipment that we do, we've chosen it for a reason, but how do we evaluate the effectiveness of that post-processing equipment in process? So Nick, you can jump to the next slide there. So to do this, we invested heavily in the equipment that we use to actually evaluate the effectiveness of our post-processing equipment. And that's ranging from our Keon's VR 6000 optical profilometer used to measure the surface roughness of our parts to our X-Rite VS 3200 spectrophotometer that's used to measure the accuracy of the dyed products that we create. Both of these pieces of equipment allow us to evaluate how our post-processing equipment is performing and to notice if our surface roughness or colors are falling out of spec. And because we have data points to this, we can also utilize our CO-EM system for traceability, and we can actually accurately track back to which piece of equipment in post-processing is not performing within our specifications. So important takeaway here is to adopt the post-processing methods that have the capability to meet your customers' requirements, and then define a way to measure the effectiveness of that equipment and the operators using the equipment as well. Because after all, kind of as we discussed, inconsistent surface finish is one of the primary reasons that customers abandon additive or are fearful of trying additive. So define your requirements, manage your materials, control the maintenance of those systems, determine the right post-processing equipment needed to meet those customer expectations, and then define how you're actually going to control and measure the effectiveness of that post-processing equipment as well. And then Nick, you can jump to the next slide there. So now we kind of made it to the final step here for best practices, which is going to be product inspection. And then Nick, you can jump to the next slide. And so this slide here is, if you're an OEM, this won't be as applicable to you. But if you're a contract manufacturer, like we are, this is actually very important. So you want to take the guesswork out of your quality control team's daily task when it comes to inspecting parts. Because ultimately, we've already discussed capturing the requirements for the products you'll be producing, but in many cases, your customer isn't an additive expert and they don't know what they don't know. So one of the best ways to make sure that you help your customer and your quality control team be successful is by establishing quality levels. And these are basically buckets based on requirements. And based on what your customer is looking for, that's where they'll kind of fall into each one of these levels, dependingly, right? And when you make these levels, you want to make sure that you're clearly defining what the requirements are for each level and what the deliverables are for them as well. And doing this will not only associate a cost to the inspections and the quality requirements that you have there, but you'll understand the quality requirements required to actually meet those customer expectations. But this will also allow your quality control team to have a better understanding of what is acceptable and not acceptable to your customer. For instance, if a process falls out of spec due to a maintenance-related issue that has caused a visual surface defect, then your team will not have to guess if this product is conforming or not conforming to customer requirements, or have to make an awkward call to the customer for consent on a defect. Instead, they can fall back on the clearly defined quality levels that have already been established and agreed upon by the customer. So if you're a contract manufacturer, set yourself up and your customers for success and build out quality levels. And this will save you time, increase awareness for your customers, and allow your quality control team to be more successful in their decision-making as well. We can jump to the next slide, Nick. And so then one of the next best practices you can have is to catalog the defects that can occur through your process. And this is going to be critical for your quality control team to be successful. And you don't want to just stop there of just making a catalog of here's my defects that can happen. You want to associate to each individual defect a root cause, corrective action, and then preventative actions as well. And this will allow even a base level technician to identify defects and know what the reaction plan is right away. So not only will you filter out defects more effectively, but there will be clear, concise, and approved reaction plans ready to go. So next, consider breaking your defects into categories. At Endeavor, we have 3 categories for defects, being critical, majors, and minors. They're located on the left of the slide here. And the defects in these categories can be moved around based on customer requirements. For instance, our standard practice may consider a small sink a minor defect on a B surface of a product. But we have some customers that consider a sink on any surface a failed part. So we would then be able to move that defect to the critical category in a custom inspection plan within CO-AM that is just for that customer. And that way, every time that customer orders that part, they'll be able to have a custom work plan and custom inspection report generated through CO-AM every time. And this process drastically simplifies the quality control process and allows the technician to not only be more confident in their decision-making, but also be able to move through the process more efficiently. So the idea is get rid of the tribal knowledge that you have and build out your defect catalog and categories. This can drastically change how your quality control team functions, and it can even be used for your operations and sales teams as well for training too. Nick, you can jump to the next slide. So next, we're going to be talking about kind of identifying the role that your quality control team plays and where those necessary controls need to be placed. We talked about that already. And so now we're going to be getting into in-process or inline inspections. So after evaluating the requirements from our customers and the defects that we typically see in our process, we made the decision to implement an inline inspection into our process after printing and initial bead blasting. So basically, we're taking the parts through the process until they can reasonably be inspected. And then the parts will funnel through our inline process. And during this inspection phase, we're actually following statistical lot sampling. So specifically ISO 2859 General Inspection Level 2 with an AQL level of 1.0. Now, don't expect many of you to probably know what that actually entails, but basically, in a nutshell, if we produce 200 parts, we would inspect 32 parts at random. If one of those parts is a defect, then we would quarantine the entire lot and perform 100% inspection. So in a nutshell, this is similar to if you had a water pipe that needed to filter large particulates from making it through the pipe, right? So you would install a filter, pretty simple, on that water pipe to catch that particulate in the water stream. So if you have large particulates, you'd put a larger size filter and to catch the particulates while not restricting the flow of water as much as possible. And that's basically what you're doing here. The water flow in this analogy would be your production process. Particulates are non-conforming product, and the filter would be your quality control team. And so kind of the next question to that is, what if you have large and small particulates? Your large filter can't catch all the small particulates. So we'll discuss that actually in the next slide, funny enough. But to close this slide out, this isn't a prescriptive method. You don't have to have an inline inspection process, and you don't have to use statistical lot sampling either. But what your best practice would be is to evaluate your risk, look at your process with a magnifying glass, and see if or where your process could use more control, and then define what the resources are that are needed for that and what the deliverables would be for those added controls or inspections from your team. Next slide, Nick. All right. And so getting into final inspection here, it kind of goes without saying, but it's kind of one of the most important quality control practices there is, and that's final inspection. And so from our little analogy we gave before, this would actually be a second fine mesh filter, for example, from the last slide where we kind of talked about the water stream and particulates. But before any product leaves your doors, it must go through a final inspection process. Now, how you perform this final inspection is your discretion as a company, so long as it can objectively meet your customer requirements. At Endeavor 3D, we perform 100% visual inspection during the final inspection phase. That's our decision as a company to throw the finest mesh filter on the process in order to satisfy our customers and limit the amount of quality escapes that we actually have. And now this is obviously a time-consuming process. It's costly as well. But kind of as we discussed earlier, it's, what was it, 80%, I believe is what it actually was, of the people from that survey that actually filled that out said that quality is what mattered the most. And so That's why we put this as such an important factor, and that's why we do 100% inspection at the end of the process, and we stand beside that decision as well. And so during the same process too, we'll actually also perform dimensional analysis of our products when applicable to the quality level that's been selected. And during this, we'll actually use statistical lot sampling from ISO 2859, just as we discussed before in inline as well. And so using statistical lot sampling during this inspection, we use this because there's added time and complexity of different projects to perform dimensional analysis. And we feel comfortable with this process due to the capability studies that we performed. So we know the dimensional accuracy of our equipment is controlled and within specification, and that's why we do statistical lot sampling here as well. And so, as with most things, it's up to you as a company to determine how you're going to perform your final inspection and what that entails. But the best practice here is to evaluate your interested parties, capture those requirements, evaluate your risk, define the controls needed to meet those customer requirements, perform your capability studies, and make sure that your process is stable and controlled. And let that kind of be your practice. And remember that 80% of those survey responders say quality is the most important factor. And be willing to make the investment and allocation of resources to your quality control team to actually be successful. And follow these best practices and let your quality department be a profit driver instead of a conventional cost center. And then Nick, we can jump to the next slide. So kind of closing things out here before we get into Q&A, a couple just closing remarks, exactly what we've already gone over. So we talked about it at the very beginning, set your quality control team up for success. You wouldn't go into battle unarmed, so don't send your quality control team in unprepared. Set them up for success. And as a company, you need to understand the role of your quality control department, what's expected of them, and how will they meet those expectations, and when is quality control needed in your process. Next thing we talked about was good inputs equals good outputs. You got to know your materials and how to control them. Train your team on your materials and supply ways for your quality control team to evaluate your materials and process when it's applicable. Also, an uncontrolled printer is going to give uncontrolled results. So define your maintenance plans, work instructions, infographics, schedules, quality inspections. If you don't maintain that printer, your team's just going to end up chasing their tails. Also, learn your processes and catalog the defects you see in your products. Attribute the root causes, corrective actions to each one, and then preventative actions, and supply your team with this information so that you're arming them to be successful and get rid of the tribal knowledge that's probably wandering about within the company. And then finally, define when and why and how you'll perform your inspections. There's no one size fits all for that, right? It's not prescriptive. So evaluate your customers, their requirements, what your risks are for not meeting those requirements, and then define and implement the controls needed to satisfy those requirements. Let that guide your process and be willing to invest in your quality control team to be that fine mesh filter for your customers. Other than that, I guess I'd like to thank everybody for listening to me blabber about quality for a while, and we can move into the Q&A section here.
Hughston, I appreciate you taking the time to put that together. I thought the information was great. For everyone who jumped in, this is Hughston's contact information. If you have any questions about anything that he talked about and it doesn't get answered today, you're always welcome to send us an email, give a phone call, go on endeavor3d.com and just kind of check in and ask questions that you might have. Also, as a note before we jump into the Q&A portion of the webinar, I did want to take a second to invite all of you to check out our next webinar on March 27th, where Endeavor's application engineer Daniel Baker will be teaming up with HP to discuss the new FR material that we just released. Also, if you're planning on attending the upcoming AMUG event in Chicago, make sure to drop by booth P1 to meet the rest of the Endeavor 3D team and talk a little bit about the technology. I'll be there, Hughston will be there. It'll be a pretty big group, so it should be a great time. Also, before we jump into the Q&A as well, I did want to let you all know that we sent out a quick poll question, and we're going to give everyone about 60 seconds to answer the question. Hughston, the question is, how many AM contract manufacturers or vendors have you worked with? And Hughston, as far as the content that we've talked about, how do you think this affects, how do you think this question kind of plays into this? Is it something where quality is going to be something that is super varied between people? Is it something that you think that's going to be pretty condensed and kind of dialed in? What do you think?
From our experience, it's been very different. We have a lot of customers that come to us that either have, if you will, battle scars from previous vendors, or they have very high expectations from some really other good vendors, right? And kind of the biggest issue, I think, with contract manufacturing, with additive in general, is there's this big discrepancy between the standards of quality that we all do, right? And so I think it's an important question to know because a lot of our larger scale production partners that we have typically have left another additive company. And for us, it's always been the same answer of they couldn't meet our requirements. They continually send us bad parts. Eventually you get tired of that, you find a new vendor and you don't look back. So I think it really does play into that on how many they've actually talked to, because a lot of people have experienced quite a few vendors, which is not a good sign within the industry specifically, because obviously if it's price difference, right, that's one thing, you're going to the cheapest place to go. But when it's a quality related to where it's, I don't care if I have to pay more, I just want my part to be what I'm expecting it to be. That's where the bigger issue is. And sometimes those customers carry, like I said, those battle scars with them from that. So the question is pretty applicable in that manner.
Awesome. Yeah, it's always interesting to come to have a potential customer or client come in with previous expectations and things like that from somebody who might not have done the quality the way that we would like it to be done. So I think it's a great answer. Okay, as far as the questions go, I'll show the Q&A results or the quality results in a second here as far as the poll, but let's answer some questions. The first question we're going to jump into is, 1 second, let me pull these up. What happens if there is a failed print in the process?
So for us, because we have an MES system co-AM, that process is actually simplified quite a bit, at least from getting parts right back onto the printer. So failed print in the process or failed parts in the process, when the inspectors are actually going through that inspection process, they have their inspection report. And so they're going to be looking for, it's a little bit over 32 different defects that we look for in just a visual analysis. So just using inline as an example, that technician is going to look at that. They're going to go through and look at this part, and you can do it individually. You can do it as a batch, depending on how you actually want to set it up. Co-AM's flexible enough to do that. So the technician will answer that question on there, and they'll mark each part or all the parts, depending on what the scenario is here, as either the part's going back to rework. They'll assign it to the new work plan wherever it needs to go based on what's going on there, what's applicable. And then there's also a reprint option. So when they hit that reprint option, it removes it straight from the actual digital system, and it'll kick it right back to the engineers who are over there in production scheduling. So it'll drop right back into the queue. They're going to throw it on the next available print because they have that order date that's already there. They know when it needs to go back on. And then from the technician side, at that point, they're following the non-conforming procedure that we have, which is going to be taken apart. You're going to deform it, make sure it's marked, clearly marked, so it can't ever end up back up in production and somebody thinks like, oh, here's the part we were missing, right? That's not going to happen. It's clearly marked, it's defined, it's put into a, specifically we use red bins at both inspection points. That way the parts go in there. Then there's a disposition that happens later on from either a quality engineer or myself to determine what the actual root cause was behind that. However, because we have that defect catalog, kind of as I mentioned, our technicians are able to very quickly communicate back to the production team on whatever that defect was they saw, what the corrective action is to make sure that we don't keep producing parts while we're having an issue, and then what the preventative action is to make sure we don't do it again. So that's definitely sped up our process quite a bit and allows us, kind of as I mentioned before, it allows our technicians to have a lot more confidence in the decisions that they're making, and allows our operations team to understand a little bit more of, you know, why did this actually fail? What caused that? Was it something that I did? Is it something I didn't do with the printer? What happened? What can we do better in the future? So that kind of the training portion really kicks in there as well. But that's typically how we would fail either a print or a part in our process.
Awesome. Next question is going to be, what machine are you using to measure powder quality, color, and for surface measurements of the printed part?
So starting on the first one there, for what machine are we using to,
So I can
Sorry, my
react.
it just yeah, my question just disappeared in front of me there.
You want me to reread it?
Yeah, if you can't, I don't have it in front of me here. Oh,
I'll go.
sorry, it changed. My bad. That's my mistake. Okay, there's a couple different tabs for those of you that can't see that. Anyway, so machine that you're using to actually measure the powder quality slash color. For us, there's a couple different ones that you can use. If you're using powder-based technology, talk to your manufacturer or your supplier first. They may have a good recommendation that may be a one-to-one for what they're using. Specifically, we have an X-Ray VS3200. We absolutely love the machine. We use it for also checking against our custom colors that we make and using it for our dyed products also. So basically, the simplistic way of doing it is we have that powder cube that's in every single build. It's very small. There's a screenshot earlier in the slides that showed where it is in the center of the build. I think it's about 1 inch by 1 inch, so it's not very large. But that actually travels with the parts through the process until it gets to the inline inspection portion, where the inspector will actually take it, separate it, make sure that it's indicated for what the lot of material that was used with it, what build it actually came from, what printer it came from, what build unit it came from. It'll make its way into the lab where then it's actually tested there. And after that point, it goes into our log, but basically you're going to take it, you're going to put it in a small little apparatus, load that on the machine. Machine's going to do its thing. It already has a standard loaded in for what we're looking for based off of load, which is basically the, for MJF process at least, your recycled material and your virgin material, put together what that was before printing, and then you're measuring after printing. And that's where we have our tolerance range set there to make sure that we're not going over that B star value for yellowing. And then for surface measurements of the printed parts, if you mean surface roughness measurements, it's our Keon's VR6000. That's an optical profilometer. That's definitely overkill for what you probably need. We chose that because we deal with so many different geometries that being able to actually get the surface roughness from a curved part is rather important to us, rather than having to use a more analog stylus system that's basically kind of drive a diamond tip across the surface of your part to get your RA or RZ valued. And your optical profilometers can get a lot more information as well. So, and there's also a little bit of cross functionality with that system as kind of an optical comparator as well. So we can get some really quick 2D measurements also. So that's the machine that we use for that as well.
Awesome. We've probably got time for about another 3 questions just to give everyone a heads up. But if we do need to reach out afterwards, we're happy to reach out as far as like answering additional questions and things like that. But I just want to give everyone a heads up. The next question, I really like this one. When working with people that are new to additive, what are some of your questions you ask to uncover key to quality requirements that the customer may not know about?
So that one is very interesting. Your mileage may vary is kind of the answer to that. It depends on how you kind of run your business. But one of the things that really makes a big difference is have your quality team create a, if you will, a sales decision tree, right? So a flow chart breaking down different things. Because the biggest thing that we've always seen is the first question that we need to know that we've seen in the past where we don't have it was, what's the application of the product? There's nothing worse than being in a quality control team in contract manufacturing, especially for additive. You have a part in front of you, a different part every single day. Sometimes you end up having hundreds of different parts you've never produced before in front of you every week. And your technician looks at it and they say, that's really interesting. What the heck am I looking at here? All I have is an STL file. What is this used for? What's the A service? What's the B service? What are the critical dimensions I'm looking at here? What is the application of the product, right? So starting from that information right there, pick the application of the product, break that into industries of where each kind of where that can flow down, right? And then what are the requirements for each one? And so we found making a decision tree really helps us in that, because based on application, if it was for say, all right, what's the application of this product? It's automotive. Great. Is this product going to be controlled via a PPAP? Are we doing a first article here? Do we not need to do a first article? Where does that break out? Are there drawings applied? Do you have your critical dimensions laid out for us? Because in our internal system, we offer dimensional analysis based into our base pricing, but that only has a certain amount of measurements, right? Because there's no reason that a customer who wanted us to measure, 2 dimensions should pay the same price as somebody who wants us to measure 40. So that's where we kind of capped it for us at 5. Anything above that, we're going to do an actual cost analysis above what we normally cost for there. So a lot of those questions are going to be really important, but also have the stop gaps there too, to where it's okay, you have a drawing and we need to know what the 5 critical dimensions are. The customer says, well, I don't have that. Well, then we can't be successful on our end. We have to have that in order to do our job well. So put those stop gaps there, right? What are those gates? And then how do you move forward from there? But kind of create that, just roll down that question list, talk to your team, and they'll tell you exactly what they need to know to actually be successful on their end. And that makes a world of a difference.
Yeah, it's great. Can I add one thing to it?
Yep.
The only thing I would say, like from an account manager side, when we talk to a customer, the one thing I'll always tell people is to tell me exactly what you know about additive and how far your knowledge base goes. Because if somebody says, "Hey, I'm super new to additive," then we can set you all up with a call with someone like Hughston who can kind of walk through those situations. That's something we do all the time, whether it's a brand new company that has just got its LLC formed to large OEMs. You'd be surprised at what people know and what they're wanting to learn, and it's exciting for everyone to want to learn. I would just encourage you to ask the questions. Like, don't be afraid to say, like, "Hey, I don't know the answer to this," because then we can bring someone like Hughston on to the conversation. But you did mention PPAPs, and it's a great entry into our next question, and this is going to be the second to last one. What is a PPAP, and what does that look like?
So for us, or anybody really in additive, PPAP is a little bit, it's a little bit different, honestly. And so kind of going through that, you're going to work really closely with your customer to figure out exactly what their requirements are, because you would imagine that your PPAP levels would be a little bit more standardized, but as what we've seen as a company, it's very much not so. Each individual company has their own requirements based on it, depending on what level it is, and everybody does it a little bit differently. They have their own forms that are required versus your forms that are required. They may accept yours, they may not. For example, or is your customer going to use the IMDS system? Are they not going to use that? Are you going to be filling out a lot of manual forms versus not? Are they looking for a full dimensional analysis? Are you going to be performing CPKs or getting the values for that to prove that your process is stable and controlled? So that it kind of breaks down into that. So there's no great answer for what it looks like other than it depends on what your customer is looking for. But it's that conversation between the contract manufacturer and that customer to figure out exactly what your requirements are and then how we can actually meet those, or if we even can. We've seen that before too, to where or a lot of our customers actually, typically when they're doing like PPAPs, they're typically coming from the automotive industry and they're used to traditional manufacturing, injection molding, and we end up having that kind of conversation, and it kind of breaks down into, oh, we didn't realize that wasn't applicable to you, or okay, we didn't realize that wouldn't work there. So you kind of you make that conversation, and then you kind of figure out exactly what those requirements are going to look like, and then you standardize on that. And you work through it together. There's going to be a lot of questions. Sometimes things aren't going to look right. There's going to be some explaining you have to do. Like with additive, when you come down to actually doing your CPK values, you're not going to get all the time that great 1.33 or 1.66 that a lot of your customers are looking for. Sometimes you end up with a 1.0, but so, it kind of looks like your process isn't very controlled or stable, but the reality is we're just bouncing around from the upper and lower limits, but you're still within your tolerance range for your dimensional inspection. And that's just because of just the additive process itself, right? Depending on where you're putting those parts in a build box, specifically like for MJF, is going to very much determine kind of what those tolerance, or kind of how you're bouncing around, whether you're on the upper limit or lower limit of those tolerance ranges, right? So it's really that discussion and kind of learning experience with those customers too. And typically what we see, we work through 1 or 2 with a customer, they start to get the hang of it too for what we're looking for, and then the process just becomes pretty seamless after that.
Awesome. All right, last question. We actually had quite a few questions come into this Q&A so far. So let's see. Let's go with would it be reasonable expectation that a part with a coplanar surfaces would have similar surface finish on both planes?
Unfortunately, the answer is probably just always going to be, it depends. It's really, really going to depend on how that part is going to be orientated in the build box, where it's going to be located in the build box, the post-processing that you're going to actually be going through with it, and then just the geometry of the part itself. So unfortunately, there's no great answer to that one without actually having like a specific part in front of you, looking at it and then going through it. So
Gotcha.
the answer is yes and no. So it'll be depends. It's kind of one of the worst answers you get all the time, but in additive, it's pretty common to sometimes yes, sometimes no.
I think I get and give that question equally at least twice a day. So yeah, it's if you basically, I guess the answer is if you have a part, feel free to reach out to us and we can take a look at it and give it a deeper review.
Absolutely.
Yeah. Okay, well, that was our last question. Again, there are some extra questions in here, but we'll reach out with some additional answers. Feel free to reach out to your account manager if you have one. We're always happy to kind of direct that conversation. And if anyone has any additional questions or topics they'd like to discuss, feel free to reach out to myself or Hughston or visit the website for more information. And we hope everyone has a great day. Thanks for stopping by.
Absolutely. Thanks, everyone.